Hello everyone, so we are back again in the chapter 2 of the differential equation, which is all about the solution of some first order first degree. So this is Engineer Domingo, instructor 1 from Summer State University. So we have several topics. So we have the variable separable, the homogeneous, and the exact, which we have already discussed. So meron na lang po tayong si linear, equation linear in a function, and the Bernoullis. But for today, we are going to discuss na po about the linear. So, defining the linear, the first order linear differential equation is an equation that can be expressed in standard form. So, if we can express the differential equation given into this form, we can say that it is a first order linear differential equation. So, we need to remember that this form indicates that it is a first order linear differential equation. So, any function with the y is called the function p, and any function that only includes the x, that is called the function q. So, for solving the linear differential equation, we have first to write the differential equation into the standard form, which is dy over dx plus the function p times y is equal to the function q times x. To the function q. So, solving for the next step is to solve for the integrating factor mu x by the formula that it is equal to e raised to the function p dx. And then, for the last step, we need to solve for the general solution of the linear differential equation by using that mu xy is equal to the integral of mu x qx dx plus c. So, for the first example, so we have this example, we need to change the equation into the standard form. So, this is the equation, or this is the example given. So, we need to divide both sides by x dx in order to cancel dx from the first function, and then to be able to get the dy over dx, we need to cancel that. We need to divide that by x dx, so the x will be cancelled. And then 0 over x dx, that still gives you 0. So, proceeding to the next equation, you will have the quantity of x raised to 5 plus 3y over x minus dy over dx equal to 0. So, this is not yet the final form. We need to still expound the equation. So, expounding this equation, that gives us that x raised to 5 over x plus 3 over xy minus dy over dx is equal to 0. So, we can divide x raised to 5 over x raised to 4. So, this will be 4. And then, 3 over x times y, you cannot divide it pa. So, that is the function. So, that is 3 over x times y. That will be your px y, since that includes the y, while your x raised to 4, that will be your qx. And minus dy over dx. So, that gives you this equation that x raised to 4 plus 3 over y times y minus dy over dx is equal to 0. So, now we can particularly change it into to the standard form. That will give you that dy over dx minus 3 over x times y is equal to x raised to 4. Wherein 3 over x represents your function p and x raised to 4 represents your function q. So, solving for the integrating factor, you have this formula, which your function p is equal to 3 over x, and then solving, you have e raised to 3 integral of dx over x. That gives you that your integrating factor is equal to e raised to 3 ln x, and by properties of logarithm, that gives you e raised to ln x raised to 3. And cancelling e raised to ln by properties of exponentials, that gives you that your integrating factor is equal to x raised to 3. So we are done with getting the integrating factor. We can now proceed to the last step, which is to solve for the general solution of the linear differential equation. So solving for the linear differential equation, you have to substitute your mu x and your qx into this equation, and that gives you the next equation, which is x raised to 3y is equal to the integral of x raised to 3 times x raised to 4 dx plus c. And now we can proceed in integrating this function. But let me correct my given. So this should be equal to x. That should be equal to x raised to 7, because x raised to 3 times x raised to 4, that gives you the addition of powers. So adding 3 plus 4, that is equal to 7. So that should be x raised to 7 dx. And integrating this function, we have x raised to 8 over 8 plus c. So now, this is not your final solution. You still need to simplify it even more. So you have to multiply both side by 8 over x raised to 3. So you need to multiply both side by 8 in order to eliminate the fraction, while you need to divide both side by x by 1 over x raised to 3, because in solving for linear differential equation, the solution, the general solution form should be that it's only the y in the left side, while the other variable should be in the right side. So, dapat po si y lang po sa left side. Always remember, ang variable po sa left side should always be the y. So, that gives us that 8y is equal to x raised to 5 plus cx raised to negative 3. So that is the general solution. So we now proceed to the next example, which is dy over dx equal to x minus 2y. So change the equation to standard form. That gives you that dy over dx plus 2y is equal to x. Your 2y is your function p times y, and your x is your function q. So now we can solve for the integrating factor with this formula, and your function p is equal to 2. That gives you that e raised to the integral of 2 dx is equal to e raised to 2x. Now we can proceed to the last step, which is to solve for the general solution of the linear differential equation by using this equation, wherein your mu x is equal to e raised to 2x and your qx is equal to x. So this is the equation. And then, as we can observe, we cannot directly integrate this. So we need to use the integration by parts. So using the integration by parts in this equation or in this function, you have to remember that your integration by parts, the integral of u dv is equal to uv minus the integral of v du, wherein you will be considering your u as your x, because in considering u, you need to use my lecture in the past topics. I will not explain it again. So the exponential is your last priority in choosing for your u. So you use x as your u and deriving your du, that is equal to dx, while your dv will be e raised to 2x dx, and integrating, you have your v as 1/2 e raised to 2x. So substituting that into the formula, you will have that the integral of u dv is equal to 1/2 x e raised to 2x minus 1/2 the integral of e raised to 2x dx, wherein the integral of your e raised to 2x dx is equal to 1/2 e raised to 2x. And that gives you the final answer, that the integral of your e raised to 2x dx is equal to 1/2 x e raised to 2x minus 1/4 e raised to 2x. So, after that, we go back to the equation, and then we know that the integral of e raised to 2x times x dx is equal to 1 half x e raised to 2x minus 1/4 e raised to 2x. So we substitute that. And then, as I said earlier, the left side should only include the variable y. So we need to divide both sides by 1 over e raised to 2x. And to be able to eliminate the fractions, we need to multiply both sides by 4. So that gives us this equation. Multiplying both sides by 4 over e raised to 2x, that gives us 4y is equal to 2x minus 1 plus c times e raised to negative 2x. And that gives us our general solution. So this is our last example. So I have different references such as the Differential Equation 2nd edition work textbook and the Elementary Differential Equation 7th edition. So you may practice solving using these references. So thank you for listening. I hope you have learned something.